Hello everyone, I am Prabhu Reddy from Sri Venkateswara College of Engineering, Department of ENC under the USN 1VE23EC076. Today's topic, that is source transformations, is related to the subject network analysis, and the subject code is BEC304. In this topic, source transformations, we need to know the basic formulas of voltage, current, and charges, because we make the use of these three or two formulas excessively in this topic while converting voltage source from current to voltage, and from voltage source to the current source. Let's see the first problem. The first problem is, a circuit is shown in the figure. Find the current I by reducing the circuit to the right of the terminals X, Y to its simplest form using source transformations. First, we have to observe what is the given data. In the given circuit, we have two terminals X and Y. Between these two terminals, the components are a voltage source of 5 volt uh, with a series resistance 5 ohms, and a voltage source of 3 volts with a series resistance 30 ohm, and we even have an individual resistance of value 20 ohms. Let's go to the solution part. First, we have been given that from the right we have to reduce the circuit. So we had a 30 ohms resistor with a 3 volts voltage source. So let's convert the 3 volts voltage source to a current source. To convert it into current source, we will be using the formula I is equal to V by R, which is again derived from Ohm's law. V is 3 volts and the value of R is 30 ohms. The final abbreviation is 3 divided by 30, that is 0.1 ohms, which is displayed as the current source in the first step of the solution, and it has a parallel resistance of 30 ohms. Always remember that in source transformations topic, we will consider the resistance only and only if the resistance is series with the voltage source and in parallel with the current source. Then, so that's why we have displayed the 30 ohm resistance parallel to the current source. And again, by simplifying the voltage source to the current source, we have 20 ohms resistor and 30 ohms resistor parallel to each other. We will further simplify the resistors to a single individual parallel resistance. We use the formula R1 into R2 divided by R1 plus R2. R1 is 20 and R2 is 30 ohms. So the final abbreviation is like 20 into 30 divided by 20 plus 30. Total equals to 12 ohms, which is in the second figure of the solution. And again we will convert. Now we have the 12 ohms, that is parallel individual resistance, and the current source 0.1 ampere parallel. So we can convert it again to the voltage source by applying the formula V is equal to IR, which is from Ohm's law. I is nothing but 0.1 ampere and V and R value is 12 ohms. We will multiply 12 into 0.1. We will get the voltage source value as 1.2 volts. You can observe here the simplified voltage source, that is 1.2 volt, is connected to the 12 ohm resistance in series. That is, again you may see the point here is The resistance is parallel to the current and in series with the voltage source. Now we have 5 ohms and 12 volts connected to 5 volts voltage source and 1.2 voltage source respectively. Now we can apply the KVL, that is Kirchhoff's voltage law, to the above diagram, that is the third figure in the solution. By applying voltage source, now by applying KVL across the whole loop, the equation we get is 5 into I. Okay, let me first say what is Kirchhoff's voltage law. It is the summation of all the voltage values in the circuit. First, we have 5 volts into I, that is I1 in the I current flows in the whole loop. So we have 5 into I plus 12 into I. That 5 into I applies for the 5 ohm resistance and 12 into I applies for the 12 volt resistance. And then comes our voltage source 1.2 ohm, 2 volts, and then minus 5. It is on regards of sign convention rules. By adding 5 and 12, we get 79, and 79 is equals to 3.8 volts. Then I, which can be simplified to 3.8 divided by 17, which evaluates to 0.224 ampere. This is the current value, or the current which flows across the whole circuit, that is I is equal to 0.224 ampere. Let's move on to the second question. The second problem is shown. The question is, we have to reduce the network shown in the figure into a single voltage source between the terminals A and B. Now, first observe the given circuit. We have a 10 ampere current source in parallel to 2 ohm resistance. We have an independent 12 volt voltage source, and again we have a 2 ampere of current source in parallel to 4 ohms, and we have a load current of 2 ampere between terminals A and B. Again, we have to simplify the circuit. For simplification, let's convert the 10 ampere and 2 ampere current sources to the voltage sources respectively, because they are connected in parallel to their respective resistances. Here, in this problem, you have to note a point. When voltage sources are in series, they can be added up and can be reduced into a single voltage source. But when we have to reduce all the current sources to a single source, all the current sources must be in parallelly connected condition. So then let's move to the next step. As I mentioned, we have converted the 10 ampere and 2 ampere current into voltage sources. The 10 ampere current source is converted into 20 volts voltage source, and the 2 ampere current source is converted into 8 volts. 10 into 2 is 20 volts, 4 into 2 is 8 volts. And as it is, we have retained the 12 volts voltage source and the load current of 2 amperes. Now we can observe here is all the voltage sources, that is 20 volt, 12 volt and 8 volt voltage sources are connected in series. So we can add up the three voltage sources and reduce them to a single voltage source. We have to note is the point we have to note is we have to check its polarity in order to give the negative or positive sign to the voltage source. 20 and 12 volt voltage sources can be given positive sign, and 8 voltage is opposite direction, so we give it as negative direction. 20 plus 12, that is 38, minus 8 voltage, 32 minus 8, which becomes 24 voltage, and the resistance also are reduced to a single series resistance, that is 2 plus 4 is 6 ohms. We have is a voltage source of 24 volts and a series resistance 6 ohm and a load current of 2 ampere. Now let's convert the 24 volts of voltage source into current source. Here we will be using the formula I is equal to V divided by R. V is 24 and R is 6. 24 divided by 6 is nothing but 4. Then the 24 voltage source is converted into 4 ampere of current source in parallel with 6. I had mentioned in the starting itself that current sources, when they are in parallel condition, they can be summed up into a single current source. Here we will be doing the same. 4 in the positive direction and 2 in the negative direction. So it will be 4 minus 2, that is 2 ampere. 2 ampere if current is parallel to the 6 ohms of resistance. In the question it was said that we should be giving it to a voltage source condition. So we'll again convert the 2 ampere current source into voltage source. We'll be using the formula V is equal to IR. I is 2 amps and R is 6 ohms. 2 into 6 is nothing but 12 voltage. So we have finally represented the final solution, that is 12 volts in series with 6 ohms in a terminal between A and B. Thank you everyone for watching the video. If you found the content useful, please like and share the video and subscribe to my channel.